Hi class, today's lesson will be from chapter 3. I'm going to share my screen with you, so hold on just a minute. You should be able to see my Cengage, not my Cengage screen, but my Excel screen for exercise 3-5, and this is going to be cornerstone exercise 3-5 that we are completing today. We're going to be using regression results to construct and apply a cost formula. So we're going to be the Doheny Manufacturing Company in this example, and they had 12 months of data on purchasing cost and the number of purchase orders. And you can see here that they have recorded information for the purchasing cost for the months of January through December. They've also given you the number of purchase orders because the purchase orders would drive the purchasing cost. The controller for Doheny Manufacturing ran regression on the data, and the coefficients shown by the regression program are as an intercept. They've got $15,021. When you see the term intercept, it really means fixed cost. Then they've got X equals a variable 1. And so because we only have one variable that we're working with in this regression analysis, the variable will be the number of purchase orders. And they're telling you what the variable cost per unit is here. X being the variable. This is the first variable because there's only one variable in this particular problem. And this is going to be $9.74. This is your variable cost per unit, in other words. And what they want you to do is to construct a cost formula for the purchasing activity, showing the fixed cost and the variable rate. And so what I've shown you here is a formula for the total cost of purchasing, which would be equal to the fixed cost plus, in parentheses here, are the variable cost. The variable cost can be found by taking the variable cost per unit and multiplying it by the number of purchase orders. So I have noted for you that the term intercept here just means fixed cost, and the X variable 1 is a variable cost per unit. So again, this is your fixed cost and this is your variable cost per unit. In part 1, they didn't ask you to put any numbers with that in Cengage, but they just wanted you to write a formula. So this is the cost formula. It's the same thing that we were doing in previous exercises. We're taking our total cost, which would be equal to the fixed cost plus the variable cost. I just broke the variable cost down into the variable cost per unit times the number of purchase orders in this case, because that was the activity that drove the variable cost. In part 2, it says if Doheny Manufacturing Company estimates that next month they will have 430 purchase orders, what is the total estimated purchasing cost for that month? And so the formula, again, I've restated for you. The purchasing cost would be equal to your fixed cost plus your variable cost per unit times the number of purchase orders. So therefore, my fixed cost was $15,021. I would just substitute that into the formula, and then my variable cost per unit was given at $9.74. I would have to multiply it by this month's purchase orders, which was also given at 430 units, or 430 purchase orders. And so the total cost of the purchase orders as the purchasing cost is $19,209. Again, that's your fixed cost plus your variable cost per unit times the number of purchase orders for this month. And that will be $19,209. And then they gave you a what if analysis. They say, what if Doheny Manufacturing wants to estimate purchasing cost for the year this time? Remember, before we just did it for a month, but now they want us to do it for a year, and that they're expecting 5,340 purchase orders for the entire year. What will the estimated total purchasing cost be? Again, it's the same formula that we used before. The purchasing cost would be equal to the fixed cost, but this time it's the fixed cost for the year. What they've given us here is the fixed cost for the month. So if we need to find the fixed cost for the year, you just have to remember to multiply this by 12 months, and that would give you the total fixed cost for the year, plus the variable cost per unit, which does not change. Remember, your rules for variable cost per unit is that the variable cost per unit remains constant no matter what the level of activity is. But in this particular case, the level of activity for the whole year is 5,340. So the variable cost would be calculated by taking the variable cost per unit times 5,340. When you do that, that will give you the total variable cost, which should be added back to the total fixed cost for 12 months. So the total purchasing cost for this company is $232,264. And again, I got that by taking the fixed cost, multiplying it by 12 months in a year to get the yearly cost of the fixed cost. Then I took the $9.74 variable cost per unit and I multiplied it by the number of units that were given for the year in purchase orders, which was 5,340. So my total purchasing cost is $232,264. Now, on the next question, they're asking you, what is the total fixed purchasing cost? Well, if it was $15,021 monthly and we multiplied it by 12, that will give you your yearly cost. The yearly fixed cost is $180,252. And then they ask you, why does it not equal the fixed cost calculated in requirement number 1? It was because this was for a year and there are 12 months in a year. So because there are 12 months in a year, we had to multiply the monthly amount by 12 months to get the total yearly amount. And this would not be equal to the monthly amount. There are 12 months in a year. I'm going to move to the next exercise that I've copied to Excel. And this exercise is using a multiple regression results. When we got multiple regression results, we're going to use more than one type of unit to base our answers on. Notice in this particular problem, we still have purchasing costs, we're still doing the purchase orders, but we also have another variable that they've added to it to make it a multiple regression. So we have two types of variable costs going on here, is what they're saying to us. The controller for Doheny Manufacturing Company felt that the number of purchase orders alone did not explain the monthly purchasing cost. He knew that the non-standard orders, for example, one requiring an overseas supplier, took more time and effort. He collected data on the number of non-standard orders for the past 12 months and added that information to the data on purchasing cost and the total number of purchase orders. So there's two sets of variable data here, one for the number of purchase orders and one for the number of non-standard orders. Again, it's for 12 months that they're doing this for. It's called multiple regression because there's two different variable costs that we're working toward here. And so the intercept is still going to be the fixed cost. Variable X1 is going to be the variable cost per unit for, I believe it's the number of purchase orders there. And variable cost per unit 2 for the number of non-standard orders is $20.39. So when you're doing multiple regression analysis, you take that basic formula, but you add two variable cost components to it. So in the requirement, they want you to construct a cost formula for the purchasing activity, showing the fixed cost and the variable rate using the multiple regression formula. So our total purchasing costs are equal to the fixed cost, it's still fixed cost, plus variable cost, but there's just two different types of variable cost. One is depending on the purchase orders and the other is depending on the non-standard orders. So X variable 1, which was $8.92, would be multiplied by the number of purchase orders for that particular month. And then X variable 2, which would have been your non-standard, would have been multiplied by the number of non-standard orders for that particular month. They didn't give us what the orders would be, either purchase orders or non-standard orders. They weren't given in this first part. They just wanted you to prepare a formula. And that formula, once again, is just a modified version of the total cost formula we've been talking about. The fixed cost is the intercept. That's the term for fixed cost here. And the X variable 1 is the first variable rate that's going to be based on the number of purchase orders. And X variable 2 is based on the non-standard order. So in part 2, it says, if Doheny Manufacturing Company estimates that next month, notice how I've emphasized that we're looking at a month now, they will have 430 total purchase orders and 45 non-standard orders. What is the total estimated purchasing cost? So we're going to start by putting in our fixed cost, which is $14,460 per month. We're going to determine what our first variable cost total would be by taking the variable X variable 1 of $8.92 and then multiplying it by the number of purchase orders, which was 430. And then we're going to add to it the X variable 2, which was $20.39, times the non-standard orders of 45. And if you look up here in the solution where I've typed it out, you can see that this is your fixed cost. This part right here is your first variable cost. This is your second variable cost. Your variable cost plus your fixed cost will give you the total cost. And in this case, the total cost was $19,213. In part 3, it says, what if Doheny Manufacturing wants to estimate purchasing cost for the coming year? And they expect, notice this year we're talking about here, they expect 5,340 purchase orders, but they also expect 580 non-standard orders. Again, we're just going to substitute it in the formula for multiple regression. And multiple regression just means we have two variable costs that we're going to be looking at. The fixed cost per year we've got to find. if this is the fixed cost for 1 month, we need to multiply that by 12 to get the fixed cost for the year. X variable 1 is $892 times the number of purchase orders for the year. It's going to be, it's going to be 5,340 because we're on this next one here. And then X variable 2 would have been the $20.39 times the non-standard orders, which were 580. And so basically the only difference between the month and the year is you have to multiply your fixed cost by 12 to get the yearly amount. So fixed cost times 12 months is total fixed cost plus your variable cost for the purchase orders, which would be $892 times 5,340. And then you're going to add to it the variable cost for the non-standard orders, which was $20.39 times 580. All that combined will give you $232,979. That's the total purchasing cost. And then again, they've asked you what is the total fixed cost. Well, it would be the intercept amount times 12. That's how we get the total fixed cost. And again, they ask you that same question, why doesn't it equal the fixed cost in requirement number 2 above? Because in requirement 2 above, it was for a month. And in this requirement, it was for a year. So to find the yearly fixed cost, we have to multiply it by 12 months in the year. So this is an example of multiple regression analysis. Our next exercise that I want to look at have to do with the cumulative average time learning curve. And we haven't talked much about that, but I think it's easiest just to go ahead and jump on into an example of what it's going to be so I can explain it as we go. This is going to be the Pullman Company, and they make aircraft engines. Pullman has noticed that in general, each new engine design is subject to an 80% learning rate. So what that means is the first unit that they manufacture, it might take them the entire 100% of the time, but that by the time they manufacture a second unit, that it will take them less time. And that less time is 80%. That's the learning rate that this company is using. So we're going to apply the learning rate to the time that it takes for us to produce the units. And we're going to come up with a cumulative total time in labor hours, depending on the number of units that we are producing. We're going to assume that the first unit produced takes 500 hours, and direct labor is paid at the rate of $30 per hour. So these two things we need to keep into consideration when we're doing this. In requirement number 1, they ask you to set up a table with columns showing the cumulative number of units, the cumulative average time per unit in hours, and cumulative total time in hours. Show results by row for total production of 1 engine, then they doubled it to 2 engines, then they doubled 2 engines to 4 engines, then they doubled 4 engines to 8 engines, then they doubled 8 engines to 16 engines, then they doubled 16 engines to 32 engines. So the cumulative number of units that they're producing, they started with 1 unit, then they doubled it, and then they doubled this unit, and then they doubled this one, and they kept doubling it all the way down through here. So we're not calculating units 1, 2, and 3. Notice 3 is missing. They're doubling it every time, and so we're calculating the cumulative number of units based on this doubling of the number of units. Now they told us that the first unit produced is going to take 500 hours. That's 100% hours that we're talking about here. It's going to take them 500 hours to produce one unit. So if we're just producing one unit, if we multiplied 1 times 500, that is the cumulative total time in labor hours. Notice these both are hours that we're talking about here. Now, let's think about this. If we are producing 2 units, the first unit probably is going to take us 500 hours, but the second unit that we produce is going to take us 80% less. So to get the cumulative average time in hours here, I would take the number of hours it takes to produce one unit and multiply it by 80%. When you do that, it gives you 400 hours. Now the next part is to find the cumulative total time in labor hours. This is how you do it. You produce 2 units, and 2 units times the cumulative average time per unit in hours, which was 400. 2 times 400 is going to give you 800 cumulative total time labor hours. Now notice the next time they doubled the 2 units that they were producing, and they were producing 4 units. Now what's happening is if they could produce 2 units at 400 hours, then they could produce 4 units at 320 hours. So what I did is I took 400 from previously times 80%, and that tells me the cumulative average time per unit in hours. So it takes 80% less time than it did before in the previous units. So 400 times 80% is 320. Then you're going to take the 4 units and multiply it by 320 to get your total cumulative total time labor hours. For 4 units, it costs them 320 hours times 4 for a total of 1,280 hours all total to produce 4 units. Notice in the next line, they skipped up to 8 units. So we would take 80% of the 320, and that will give us 256 hours. 256 hours is for 1 unit. We would multiply that by 8 units that we're producing, and that will give you 2,048 total time labor hours, cumulative total time labor hours. And so notice they jumped to 16 here. From 8 to 16, they went up. The learning curve was 80%. The learning rate was 80% of 256 hours, which will give you 204 hours and 80 parts of an hour. And we would take that and multiply it by 16 units that we produced, and that would give us 3,276.8 cumulative total time labor hours. And then one more thing, they said, well, what if we produce 32 units? That's doubled again. The 16 units times 2 is 32. And then we'll take 204.80 and multiply it by 80%, and that'll leave you with 163.84 cumulative average time per unit in hours. And then we would multiply this unit in hours times 32 to get the total cumulative total time in labor hours. So 32 times 163.84 gives you the cumulative total time. In part 2, it's asking you, what is the total labor cost if Pullman manufactures the following number of engines? If they manufacture 1 engine or 4 engines or 16 engines, and they want you to round it to the nearest dollar. So what we have to know is how much time it takes us to produce 1 engine. And the cumulative total time in labor hours was 500. We would multiply 500 times the $30 that was given as your labor rate. It's given right here, that $30. So 500 times 30 will give you 15,000, which is the cost of your labor to produce 1 engine. Again, it was 500 cumulative total time labor hours times $30 per hour will give you $15,000 that it cost you in labor to build 1 engine. If you're building 4 engines, because there's a learning rate that's associated with this at 80%, our number of hours to produce those units per unit go down. The total cumulative time for 4 units was 1,280 hours. We'd take 1,280 hours and multiply it by the labor cost per hour, which was $30, and that would give you the labor hours for 4 engines. If we're computing 16 engines, we're going to drop down here to 16. We're going to pick up the total labor time that's cumulative at 3,276.80. Then we would multiply this by $30, and that would give you 98,304 as the total labor cost for 16 engines. So 16 engines took us this amount of hours here, and these hours would be multiplied by $30 an hour to get the 98,304. And they didn't ask you to do it, but then I added up all these to get the total labor for all of those engines. But they did not ask you to do that. But they did ask you to find the labor cost for 1 engine, for 4 engines, or for 16 engines. In the second part of part 2, it says, what is the average cost per engine for each of the following number of engines? We had 1 engine, 4 engines, and 16 engines. So for 1 engine, we're going to take our total labor cost, which we just found, and divide it by the number of engines. So our total labor cost for 1 engine was 15,000. We would divide that by 1 engine, and that of course will give us 15,000 as the average cost per engine. Since there was just 1 engine, the amount of the labor cost would be divided by 1 engine, which will leave you with 15,000 as the average cost per engine. In the second part of this, it was for 4 engines. So the cost of 4 engines was $38,400. 38,400 divided by 4 gives you 9,600 as the average cost per engine if you produce 4 engines. If you produce 16 engines, the average cost goes down. For 16 engines, the total cost was $98,304. If we divide that by 16 engines, it will give you $6,144. And then there is a what if analysis. And it says, what if Pullman is preparing a bid to build 16 engines? If necessary, round your answers to both parts to the nearest dollar. In the first calculation, they wanted you to calculate the budgeted labor cost for an engine design which Pullman has built before. So they're giving you some information that's important in solving this particular problem here. They're telling you that they built this engine before and that you are to assume that 16 of these engines had been made previously and the first engine took 5 hours. So 16 engines had been built previously and 16 engines took 33,276.8 hours to build. So what they're asking you to do is, you had previously built 16 engines, we're going to build 16 more, so we're really building 32 engines. So you'll want to go to find the cumulative labor hours for 32 engines, and you'll want to subtract from it the cumulative labor hours for 16 engines. And what that will give you is a difference in labor hours that we would multiply by $30 per labor cost per hour. And that would tell you that the total labor cost is $58,982.40. Again, we get that by taking the difference in labor hours, which is 1966.08, and multiplying it by $30, and that will give you $58,982.40, which is your budgeted labor cost to produce those extra 16 engines. There's another way that you can calculate the budgeted labor cost for this particular bid too. And again, we're still assuming that they have built 16 engines before, and they're getting ready to build 16 additional engines. So what I did is I took the labor hours and multiplied it by the labor rate. So for 16 engines, the labor hours was $3,276.80. I would multiply that by $30 to get my total cost of the labor for 16 engines of $98,304. And then I would find my total cost for 32 engines. if there's 32 engines produced, it's $5,242.88, or 5,242.88 hours times $30 for each of those hours. The total labor cost for 32 engines is $157,286. If you subtract 98,304 from 157,286, it will leave you with 58,982.40. Notice this was equal to this, so there's two ways that you could have calculated that cost. And then in the very last part, it says to calculate the budgeted labor costs for a new engine design that Pullman workers have never made before. And you're assuming that the first unit takes 5 hours. So if you've never done them before and you're doing 16 engines, we want to find the total labor hours for 16 engines. For 16 engines, the total labor hour was $3,276.80. We would multiply that by $30 to get the total labor cost for 16 engines, which was $98,304. And the last exercise that I want to do with you is actually on Cengage. So I'm going to stop sharing this for just a second. And I'm going to go back and I'm going to share my screen with you. And I'm going to try to pull up Cengage. So let's see if I got Cengage pulled up. I don't see that I have it pulled up. So let's see if I can find it. Bear with me just a minute. Okay, we're still recording. I'm sorry. I goofed up there. So just bear with me for just a minute. Let me see if I can get it here. Okay, we should be able to see this now. So let me move my screen out of the way so I can see what I'm doing. We're looking at exercise 3-08 for Cornerstone. And it's just asking you to determine what is a flexible or what is a committed resource. And we need to talk about that for just a second. When we talk about a flexible resource, what we're saying is that if it's flexible, a flexible resource, it's not completely used up. Well, it is. It's as we as we incur a flexible resource cost, we will use it up. So there should be no unused amounts left over. If it's a committed resource, what that means is that we are committed to that resource, whether we've used it up or not. So we could have some of that resource left over. And in this exercise, they're asking you to decide whether some of the costs that are in this exercise are going to be flexible or committed. Now I'm going to attach a Excel spreadsheet of some notes to this chapter, and it might be in Word this time, where I have the definitions of these flexible committed resources. But they're not too hard to do. So I'm just going to go ahead and look at this exercise with y'all and try to get you on track as to what they mean by flexible resources and committed resources. State University's football team just received a bowl game invitation, and the students and alumni are excited. Holiday travel agency located close to campus decided to put together a bowl game package. So we're going to be a travel agency and we're putting together a bowl game package. For $50,000, a 737 jet could be chartered to take up to 170 people to and from the Bowl City. A block of 85 hotel rooms could be confirmed for $400 each. A 3-night commitment. Holiday travel must pay for all the rooms in advance and cannot cancel any of them. The day of the game, a pregame buffet will be catered at $30 per person, and each person will receive a game favor package. So each person that goes to the buffet will also receive a game favor package. And that package consists of a sweatshirt, a t-shirt, a commemorative pin with the school and bowl logos, 2 pom-poms in the school colors. All items in the favor package can be purchased by Holiday Travel on December the 21st and will cost the agency $25 per set. Buses will be chartered in the Bowl City to transport participants to and from the airport and the game. Each bus holds 50 people and can be chartered for $500. The bowl game is scheduled for December the 28th, and the trip will span 3 nights, December the 26th, 27th, and 28th. Purchasers must reserve their package and pay in full by December the 20th. For requirement 2A, it says for each resource, determine whether it is a flexible or committed resource. The jet rental is a resource. We have to decide whether it is flexible or whether it is committed. And remember, it said that a 737, for $50,000, a 737 jet could be chartered to take up to 170 people to and from the bowl. What that's telling us is that this is a fixed cost. And because it's fixed, we are also going to have to commit to that cost. And we might have enough people to fill up the plane, but it doesn't matter if we just have 2 or 3 people that are going to the bowl game. Then we still have to have a 737 jet. So this is an example of what we call a committed resource, because we have to commit to paying that $50,000 no matter how many people get on that jet. It's a committed expense, and therefore, you know, it could be used totally or it could be part of it unused, but it is committed. It is a committed type of resource. The hotel rooms, where it says a block of 85 hotel rooms could be confirmed for $400 each. Travel must pay for all of the rooms in advance and cannot cancel any of them, because they have to pay for it in advance and they can't cancel any of the rooms. It too is a committed expense. A committed expense is a resource that we've entered into, and it's possible that we could have some unused hotel rooms. And so this is an example of a committed type of expense. Now for a buffet, when we read about the buffet, it says the buffet will be catered at $30 per person. Well, right now we don't know how many people are going to be attending the buffet. So this is an example of a variable expense, and it is considered to be a flexible expense. So it's flexible because even though we're going to be charging them $30 per person, we might have some people who choose not to come to the buffet. So the buffet is going to be variable depending on how many people attend. It is not a fixed type of expense. It is a flexible type of expense. The favor package is also going to depend on the number of people that probably go to this buffet, because it says, and each person at the buffet will receive a game favor package. So this is going to be a variable item, and it too will be flexible. And for the buses, it says the buses will be chartered in the Bowl City to transport participants to and from the airport and game. Each bus holds 50 people and can be chartered for $500 a bus. So this too is a fixed type of cost. It is a committed expense because it holds 50 people. If 30 people get on the bus, they still got to do it. So there might be some unused portion left over in there, and it is committed. So I'm going to check my work just to make sure that everything's okay here, and you can see that it is. Now, for each of those resources, determine the type of the cost behavior displayed. Is it variable, fixed, mixed, or what we call a step cost? Well, we've already said that the jet rental is going to be chartered, whatever the jet rental cost us. That $50,000, I guess, was the jet rental, is the fixed cost. So this is a fixed cost. My hotel rooms are also a fixed cost. The hotel rooms are $400 each. The buffet depends on how many people attend that buffet. It's $30 per person. That's the variable rate, in other words. So $30 times the number of people would give you the variable cost. This is a variable item. The favor package is based on the number of people who are at the buffet, and it too will be variable. It's a variable type of cost. Now, your buses is a little bit different, and so we need to talk about it. When we looked at the buses, it says we could charter the buses they hold $50, 50 people at $500 a piece. So what that means is this 500 is fixed if we take one bus. But if we have to take another bus, it goes up an additional $500. So this is what we refer to as a step cost. It is a fixed cost for one bus, but if we have to take two buses, it'll be $1,000. If we have to take three buses, it'll be $1,500. So it's what we call a step cost, and a step cost means it's fixed to a certain extent, and then it jumps up a step. So if we have to take two buses, we have to pay $1,000. If we take one bus, it's $500. So each bus is going up by $500. So this is a step cost. It's an example of a step cost, and it's probably going to be a step fixed cost. And we'll check the work. And that's all I want to talk to you about today. Thank you for bearing with me. And I'm going to stop the recording now. Bye-bye.